right, time for another movie. This is, again, some student code. The pull request that where this code was posted, the student thought there was a problem with the draw array function. So that's where I started looking at it. I've moved a few things around. I've closed up these two functions up here, make array and a row and make array, because they're not relevant. They work fine. And so let's see what this code does, and then let's see how we can understand it and maybe make it a little easier to figure out what's going on. Okay, so if I run it, nothing happens right now because I didn't actually call the function. All right, so it looks like we're drawing a Sudoku board, and it definitely looks like something is off. The numbers are not all inside the board. There's an extra line over here. The numbers are also not really centered in the squares, and that sort of seems like a mostly cosmetic problem, but there's definitely something wrong with some combination of the logic of drawing the board and drawing the numbers in the board. If we do peek into make array row, we see that we're in fact making a board that's initially all zeros, which is fine. Okay, so the question is, what's wrong here? Why isn't it like we just kind of know what we want it to look like? And it kind of looks like if we could just shift everything over, like shift the numbers to the right, they would be more or less in the right place, or shift the board to the left, it would be also in the right place. There's this extra line over on the left. I'm not sure what's going on with that. And so then I want to look at this code. And the first thing I see, is that on this screen, at least, which is my laptop, which is a big laptop, I can't see the whole line. So that's almost the very first thing. Is like, these lines are too long. I can't understand what's going on. So I might just start by like breaking things apart, putting each argument on its own line so I can see. All right, and which also shows me something, which is that this expression is almost the same as this expression. In fact, if I put parentheses around this, I think, and then let the editor show me when I highlight one expression, I see the same expression somewhere else. That expression is occurring here and on line 19 and on line 21, also again on line 30, and maybe that's it. So that's the first thing I notice. So knowing nothing else, I might think I want to get this expression out and make a variable just to hold that expression, so I can just pass that variable in here and maybe make this line a little shorter. Now I look at what draw line is doing. If I remember, draw line takes, as I recall, an x and a y and a second x and a second y and then a color and then a width. So obviously these two arguments are both x, so I can make the code both shorter and a little more legible if I define a variable x inside this loop and make it the value of that expression that was repeated. And so now draw a line from some x value and the y value 0 and another x value and the y value height, black width, and this will probably all fit on one line. I can use Control J to join these lines up. Delete this extra space. Okay, and so now I can see we're figuring out the x value. So this is basically drawing a bunch of vertical lines. So we have a I value is going from 0, or a loop that runs 10 times, as we know, from 0 less than 10 means 10 times. And so that's 10 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are the thin lines, line 1. And then obviously we're also drawing some thick lines, and maybe maybe there's no thin line under there. Okay, so why don't I just, since that was kind of fruitful, let me do the same thing with the other arguments. After each comma, I want to put a new line, format this, and this one is going to 11 for some reason. I'm going to worry about that later, but it has the same whoops, I missed one. Same feature that this time this expression is in common, and it looks like, so this is an x value that's going from somewhere to somewhere else. This is a different x value, but the two y values are the same. So that suggests maybe we're drawing the horizontal lines with a y value that's constant for each line. And these two expressions for the x values are a little bit complicated, more so than like the 0 and height. But now I kind of see what's going on, which is this loop, this first loop is drawing the vertical lines at each given x value, 10 of them. This one is drawing the horizontal lines. For some reason, it's drawing 11 horizontal lines, which seems weird because the Sudoku grid is 9 by 9. And so there's 10 lines because there's 9 rows and 9 columns, but there's an extra one for the edge. So it really seems like this ought to be 10. And I'm just going to go ahead. And this is another thing. I suspect what happened here, either that was just a typo, or possibly in an attempt to get something to sort of come out the right place, the original author changed the 10 to 11 because it kind of seemed to work, but it just, the logic of the situation says it's got to be 10. So I'm going to go with that. And if it doesn't work with 10, then I'll figure out like what's going wrong. So let me think a little bit more about what these other expressions are. So this is drawing the line from on a given x from 0, which is kind of the top, and height is the bottom. So just for grins, I'm going to also give those names, even though they're pretty simple. Bottom equals height. So this is kind of silly because I've just made a variable whose value is just another variable, but it's semantically meaningful in the sense that the point of this expression or this line is to draw a vertical line from the top to the bottom. And if the top happens to be 0 and the bottom happens to be height, then that's fine. But we could imagine maybe there'd be a different top and bottom if we wanted to change the size or the position of the board. Okay, and by the same token, these are drawing horizontal lines, and horizontal lines probably go from left to right. So let's copy that expression or cut it. I'm going to put left there, and then I'm going to go and define a variable named left. And then I'm going to do the same thing for this and call it right. And so this, I'm not trying to remove duplicated code. I'm just trying to give things names that are meaningful, which also has the nice function of making the lines shorter, because instead of this big, long, complicated expression, I have a name left and right. Okay, so now that also sort of peeking ahead, if we look at the end of this line, yeah, these two loops are drawing lines of width 3, which are these thick lines, since the Sudoku grid is kind of divided. And I guess we should probably run this again just to make sure. I haven't, as far as I know, changed anything. And in fact, it seems like I have not, except possibly that I did change that 10 to an 11. But it didn't seem to have any visible effect. So I'm going to call that good. What would that would have drawn an extra horizontal line or something. Okay, so we'll worry about exactly what's going on there later. Okay, so we've got top, bottom, left, and right. So these are the top, bottom, left, and right of the board, the whole grid. So now let's do our same old trick. Split this up at the commas. Let's see, where's that? Height. All right, fix the formatting. Okay, so this is another drawing 4 lines because there's 1, 2, 3, 4 fat lines. This one is going from some x to another x, or sorry, the same x. All right, I think this is the same. Let's see, if we highlight this much, we get times I. Yeah, we get this same expression that we used up here for the x in the loop where we draw the thin lines. This time it's times 3 plus this other thing. But nonetheless, this thing that I just selected is a sort of common expression. We can't use the x variable that we defined before because it was in a different loop, but we can do the same maneuver and just copy that out and replace that x times 3 plus height divided by 10. We'll worry about what that means in a second. And I imagine this is the same expression, so we can just replace that with x. And this time it's both of these are actually the same, so it's x times 3 plus height. So if we wanted to, we could do that up here, height divided by 10, and just make this x, which is kind of nice because now it's like the line is just clearly drawing a line from some x and a y, which is 0, and the same x and the height. Now we define 0 as our top is 0, and these lines, they're fat, but they should be going the same place from top to bottom, so we'll use the variables again. Join those lines up, reformat. All right, and one last, you can kind of get where this is going. Probably is going to be very similar as the second loop that draws the thin lines. We would imagine that we're going to compute some y value, and indeed we are. So this expression is that, and so that can be y. Highlight this, see it's the same. That can be y. And let's see what this expression is. This is in fact the same expression we used before as left, which makes a lot of sense because although the line is fat, it goes from the same place, so it goes from left. And this should be the same expression as we used before for right. So that makes a ton of sense. Join those lines up. All right. So this has done a couple of things that are worth noting. So we've made the code a little bit shorter, like certainly these lines are shorter. It all fits in my screen now, or at least everything in this function does. So that's nice because we can read it. We can also more easily compare that, for instance, this draw line is drawing a line from left on some y to right on some y, black with 1. And this line is doing exactly the same thing, except with width 3. So that's nice to note. That also lets us check a thing that we can look and see that this expression is common. So these y's go, there's 10 of them, but they're always height divided by 9 times something. And this one is always height divided by 9 times something times 3. And so that at least means that these lines will all overlap these lines, which makes sense because the fat lines, in fact, overlap the thin lines where they occur. And so now let's check the same thing with the vertical lines, where I feel like maybe this is not going to be right because we can see visually like they don't line up right. We would expect this fat line to be on the same position as the first thin line. So if we look at the x values we computed, this part was common all the way up to the I, and this one is the same times 3, and then plus this height divided by 10. And I don't really know what that's about, but it can't be right because the fat lines need to overlap the thin lines. So my first thought is, and I'll be a little timid about this, and I'll just put a comment out the end of that line. So it's still there if I want to bring it back. Okay, that doesn't look fantastic, but at least the fat line now lines up. 2, 3, 4, 5, 6, 7, 8, 9, 10. And it looks like now our problem is that our horizontal lines are not starting at the same place. Like, so our left value is not actually where the first line is, and our right value also isn't at where the last line is. So that is perhaps easy to fix. So I'm going to call this change good, even though it just made things broken in a slightly different way, but it actually looks like progress to me. Okay, so now I need to dig into, I just grabbed these expressions before. I didn't really think about what they meant. And if I did think about them, I'd get a little weirded out because so these are left and right. I gave them those names because that's like what they mean. So that means they're values on the x-axis, but we're using the height to figure out what they are, and I'm not entirely sure what that's about. But it probably has to do with the fact that the height is the smaller of the dimensions, at least on this screen. And so, I don't know. It comes out to be basically that value, which is like kind of looks like maybe roughly the right place. So that's our left. Width divided by 2 minus height divided by 2 minus height divided by 10. So that gets us to there. But if we look at which were the loops that draw, so these draw left and right. Oh, but these compute. So this is width divided by 2 minus height divided by 2 plus height divided by 10 times I. So that's like if width divided by 2 minus height divided by 2 is some place on the x-axis, and then we're going to add height divided by 10 kind of looks like the size of the squares, right? Because I don't know, there should be 9 of them, so 10 is a little smaller. And so that when I is 0, it's right on this value, and then the next time through it steps over 1 square, and when I is 2, it steps over 2 squares. So that kind of suggests that, at least in this loop, this is kind of function as to the left, and likewise in the fat line loop, we see it's highlighted. But in this, it is not. So again, let's see if we change the left, comment out that maybe gratuitous height divided by 10. Okay, so now the left starts at the right place, and the right has a similar problem. It is going too far. What's going on here? So these are the left, and so I mean we can kind of see it's actually just going 1 square's worth too far, it looks like. So we could just sort of hack it up and like subtract a height divided by 10. But I'm not super happy with that. But let's just see if that looks right. Okay, so that looks right, but let's think for a second about what that is. Actually, let's not even think too hard about it. Because now that we see what's going on, or if we're agreed that this is, at least for the moment, the value of our left point, and then we know that the lines, the x values of the line go from, and so now, actually before, as I was just highlighting that, I noticed, okay, so this is left, which means anywhere that it occurs, we can replace that expression with the value left, and that starts to make this also a little more clear. So the x values of the vertical lines are the left plus height divided by 10 times I. So that makes me want to make another variable. I can take these parens off. So the square size. So everywhere we say height divided by 10, what we're really talking about is the size of 1 square. And so now this makes a lot of sense, that the x value of the vertical lines is the left value plus the number of squares we've moved over. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the last index in a loop that goes up to less than 10. So that's promising. And we can do the same thing here. So we replace this expression, that's the same as left. And this expression is the same as square size. And there was probably one other place. Yeah, down in, oh, that's in draw, right? Okay, so we'll come to that later. And this also now brings us to, these loops all look kind of similar. This one is going from left plus some number of squares. This is going, oh, height. Interesting. I think of the line just going from top to bottom, but this is kind of doing the, oh, sorry, height divided by 9. Oh, right. So this is kind of hiding the fact. So if we draw the lines from top to bottom, we can add top here, which is sort of the equivalent of left on the vertical axis. Since top is 0, that doesn't actually change anything. But we can do the same thing down here. And then I noticed that height divided by 9 is not the same as height divided by 10, which means these squares aren't actually square, which is a little funny. And again, I just kind of want to go with the logic of, like, these should be squares, which means we should be moving the same amount in both the horizontal and the vertical. And so now I've broken it again. So what is going on here? Okay, oh, the other thing I think I'm going to do, I'm going to take out this draw array for a second. Okay, so now we're back to drawing a little too far, which is maybe this is where I was going a second ago. So we computed the right in this way that I'm not really sure I understand. I'm not really sure I understand how left, like why this is a good value for left, but it's fine. It seems like a good place, but this is obviously not a good place. And now that I have, let's define square size a little earlier. Now I can define right in a more logical way as left plus however many squares I'm going to move over, which is 10. So 9 plus, or sorry, 9 squares, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9 squares on the Sudoku board. And so I bet, look at that. Now the right side of the board goes to the right place. And likewise, the bottom goes a little too far because it was defined as 0 to height, but our square size is, so if this was 9, it would probably look right. Because now we're absolutely dividing the height into 9 parts. But when height was 10, or 1/10 of the, sorry, when the square size was 1/10 of the height, then 0, the bottom being the height, is actually also a little too far. So let's do the same thing where we say it's top plus the 9 squares that we want to account for. And now with the slightly smaller squares, it'll still go to the right place. And so now we have a nice looking Sudoku board. It's a little jammed up against the top because it starts at 0, but all the other dimensions are determined by the square size, which is determined by the height. So there's a couple things we could change about that to maybe make it draw in a little bit of a different place or whatever. Maybe we'll come back to that at the end. But for the moment, this seems really good. We can see like the logic of these, like these lines are all the same. These draw the skinny lines, these draw the fat lines. Obviously the fat lines are less frequent, so we only need to go every 4. Could possibly like do it in one loop and just use the, on the certain indices you want to draw a fat line, otherwise you want to draw a skinny line, but I'm going to leave that alone for now. Okay, so now let's get to draw array, which was what the student originally asked about. And I noticed earlier that when I had highlighted this expression, it also got highlighted down here which makes a certain amount of sense, that we're drawing the text on this board, and so we're using some of the similar expressions. So that actually suggests that this variable, and probably all these variables, like they're not using any values that like came in as arguments to draw board, so we could move them outside. And unfortunately, this is not going to work for a reason. Syntax error, top has already been declared. It turns out there's a top defined in some of the code in this environment. So I'm just going to, for the moment, let me actually do one thing. I'm going to put these back for a second. I'm going to use the rename symbol function to rename that board top. So it changes because these were all defined here. I'm going to, just for consistency, rename the others. And now everything should work the same. But now, since those variables don't exist, I believe everything still works the same, just the variables are defined outside of drawBoard, which means we can use them in drawArray. So now this expression here is actually our board left, and this expression is our square size, and this height divided by 9, that was like the other square size. I don't know. I made them the same when I drew the board, so it seems like I should make them the same here. So I need to uncomment drawArray to see what happens. I suspect these are not going to be in quite the right place. Well, they're not terribly off. And I think the problem here is just that the coordinate of the character is like the bottom left corner, which is, what is this? This is going from 0 to the length of the board, which is the number of rows, and then 0 to 10, which I think is, that seems wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, that's the I, so that's the column. Oh no, that must be the row. X, Y. Yeah, sorry, Y. That's the row. So we're coming down. Oh, I bet what's actually happening. Let me show you what's happening. So let's just change the top, because you know the board is jammed up at the top. So let's change the board top to be like square size divided by 2. Maybe make it a little bit more. We'll make it a whole square. So now we'll be jammed up against the bottom. Oh, and you see there's actually these extra numbers. 2, 3, 4, 5, 6, 7, 8, 9. Is there even one more? Oh, right, because these aren't using like top and bottom. So that's one thing they should be doing. We use board left, but this should be board top. Now we'll see, perhaps. Yes. Now we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows of numbers, which makes sense because we ran this loop 10 times. So we don't actually want that. Again, the board is 9 by 9. The loops kind of logically have to be 9 by 9. Or we could do, we could use the fact that the board is square and just use b.length again. We could use the first row to find out how many columns are in each row, or we could be extra careful and use the current row. It's always gonna be the same value. None of these, they all come out the same. We could just put 9 in all of these. So what is going on here? Oh, and then I hadn't noticed this. When we made our array, we're just looking at the signature here. Make array takes a number of rows and a number of columns. But it is for some reason making 10 columns. So it seems like we're getting 10 rows. So I think something got swapped somewhere. But at any rate, again, the logic of the situation dictates that a Sudoku board is represented by a square array. So it's got to be 9 by 9. And so if we fix that, now we're getting the right number. They're just all offset by 1. And I think that's because the positions, like when we're at the zeroth, that sort of is the top and the left, which is right there where the mouse is. And the character is drawn with its bottom left corner at that same position. So in order to get this to work right, we got to shift everything down at least by or like a square would push it probably a little too far. But let's do the same thing as we did before. So we want the X to be, we'll just grab what we've got right now. And we want the Y to also be, we'll replace what we just took with X. And we'll copy that expression, which we're going to call Y. So this should be exactly the same. And now we can say, okay, we want the Y to go down a square. That's a little too far, so let's say half a square. That's not quite enough, so we could say, how about 3/4 of a square? Okay, and now the X also might be nice to be centered. And this part is not like super scientific, partly because fonts are a little wonky. But that looks basically right. And note that now draw array is also using the constants we defined, which are themselves defined largely in terms of either the width and the height or the square size. So we can do things like, we can make the squares smaller, height divided by 12, and the board shrinks. Or we can't make it much bigger, but we could make it fully the right, like span the whole thing. But because we've pushed the board size down, now the whole thing doesn't fit. But that was just an experiment anyway. So we can actually make this a little nicer, but before we do that, I got to fix one thing. I noticed there was I noticed that these braces, like there was a gap, and the code is formatted right, but it felt like there should be a brace right here. And the reason there's not is because there's no opening brace on this for loop, which is syntactically legal, but I really strongly encourage you always use braces around the bodies. All right. Okay, so what was I going to do? Oh, I wanted to fix this positioning a little bit. And this gets back to some of the images challenges. I think what I would do is I would say the board size is going to be let's start with just the smaller of the two dimensions. So with the minimum of the width and the height. So if the height is the smaller one, as it is here, the size of the board will be that. And now we can say the square size is the board size divided by 9. And the top, all right, sorry. And so let's go back to, well, if the top was 0, that would work. But if we made the board size, what we might like is, let's say we made the board size a little bit smaller. So we're going to multiply by 0.8. Okay, but now we might want the board to be centered vertically. That's another, there's been problems on problem sets for this. If we took the height, which is the actual height of the drawing area, and subtract the board size, and that's like basically how much space there is, the whole height minus the board size is like this area, but we want to divide it evenly. So we do that, divide it evenly, and that will push it down. And now we can, remember I said I didn't really understand how board left had gotten set to this particular value. Now we can do the same thing and say we want the board to be centered. So we just take the width minus the board size and also divide it by 2. And now it is nicely centered. And so now everything is really driven by the board size, which is should be, well, and the width and the height obviously to center the board. Obviously, if we wanted to position the board in some different way, we would do some different math. But basically, we take the smaller dimension. We want the board to be a little bit smaller than that dimension, like 80% of it. And then otherwise, we center, we make the squares the size they kind of have to be. If it's going to be a 9 by 9 grid, it's got to be 1/9 of the board size. And now everything is positioned in the right place. We did a little fudging on the XY of where we draw the characters to get them to sort of come out in the right place. That was more by eyeballing. And we fixed this, made the array 9 by 9, which it kind of has to be, given just the nature of a Sudoku board is 9 by 9. All right, so that's really all I wanted to show. The point, again, is that by giving things names, even if you just keep exactly the same expression, it lets you see the structure, like the kind of the logical structure of what you're doing, and see common expressions. See that this is just, the same x expression in two places, and this is the same y expression in two places. It's just a lot easier to see than seeing that two complicated expressions are the same as each other, especially when they don't even fit on a line. And then the other thing that lets us do is once we've defined things in terms of these names, that's kind of a little bit more abstract. And eventually we got down to defining these pretty abstractly in terms of other named values. So the x is a function of the left side of the board plus the some number of squares, which is kind of logically what it's got to be. But we don't have to, we can just see that now because the names tell us what the different pieces of the more complex expression are. So if we put back like board left, as this, and then an expanded board size to be this, and then square size to be that. I mean, we could mathematically it would be the same. It would be almost impossible to tell what's going on. Also lets us see the commonality, both of literally the same, like this x is the left and the square size times I, and this is that same thing times 3. Also the sort of parallel structure. So this x is computed from the left and the square size, and the y is computed from the top and the square size, which again, when you see it, makes a lot of sense in that we're drawing vertical lines from the left and we're drawing horizontal lines from the top. So hopefully, or pretty clearly, this fixed the problem, addresses the problem that the student had asked about in their PR. I'll note that it was maybe not as much a problem in draw array where they had asked about as in draw board was a little bit wonky to start with, but now everything fits together. Also, we can see that because draw board and draw array are using these common variables, like they're much more likely to work together, and we can make changes. Right, if we wanted to shrink this board a little bit, everything else would still work because they're all using the same abstraction. Okay, so I think that's enough. There's other things we could do, but that addresses the question that was asked in the PR. So I'm going to leave it there. Thank you for watching. Hope this was helpful.